We're going to look at some conversions. So whenever you're approaching a conversion problem, it's a good idea to have out some of your conversion factor sheets. So I've provided several on Blackboard. A lot of them have similar conversion factors on them. Whichever one you're most comfortable with using, go ahead and use that one. So I have all of them, all of them right here. So all of these will work. As I said in the PowerPoints, a lot of conversions have more than one conversion factor that'll work. So it doesn't matter which one you choose, as long as you are canceling out what you don't want and keeping what you do want. And we'll see that in a moment here. All right, so let's look at number one. Number one, we are taking 0.5 inches and we want to convert that into meters. So the first thing you want to do when approaching a conversion factor type problem is figure out what type of conversion factor it is, because that will help you figure out which sheet is going to apply. So in this case, inches to meters, this is English to metric. So English to metric, we're going to be using these tables here. Okay, so how do you know which conversion factor to use? Well, we're trying to go between inches, an English unit of measurement, to meters, a metric unit of measurement. So what I want to do is I want to look in my conversion factor tables and see if I can find anything that goes between inches and meters. Now, the unit of measurement that we're using here is length. So I'm going to look in the length section. So it doesn't matter which sheet you use, they're all separated by length, mass, and volume. So in the length section, I have two conversion factors that have inches in it. I have a conversion factor where 1 inch is equal to 2.54 centimeters, and another one where 39.37 inches is equal to 1 meter. So let me write that one down, because this one, 39.37 inches, is equal to 1 meter. So this is my conversion factor. So why did I choose this one? Well, because it's going between inches and meters. And that's exactly what I'm trying to do here. So this is the most direct conversion factor. So once I have a conversion factor going between the two units, I can start my dimensional analysis, or what I call railroad tracks. So I start with kind of like this little plus sign, and what's always going to go in the upper left-hand corner is the number that I'm starting with, that the problem gave me. And it started with 0.50 inches. And I always put my units there with it, because once I use my conversion factor, I need to cancel out inches and keep meters. So having the inches up here in the top, that's going to help me figure out, okay, which part of this conversion factor goes on top and which part of this conversion factor goes on bottom. So in this case, since inches is on the top, I want the inches portion of this conversion factor to go on the bottom. I need the inches to be on opposite sides of this horizontal line so that they cancel. So I'm going to put my 39.37 inches on the bottom. That's going to put my 1 meter on the top. Now, since the inches are on opposite sides of the horizontal line, inches cancel, and now all the units I have left are meters. So once I do this calculation, I know that my answer is going to be in meters. Now, how do I do this calculation? We need to remember this horizontal line, that is a division line. The vertical lines are multiplication lines. Okay, so we're taking 0.5 multiplied by 1, and we're dividing that by 39.37. So let's plug that into our calculators and see what we get. And I get a huge number. And I don't mean a huge number, it's actually a very small number, but it's a lot of digits. So 1270, and there's a lot more digits after that. But to know how many digits I want to put my answer in, I'm looking at significant figures. So to figure out the significant figures I want to report my answer in, I go back to my original number. So I'm not going to take into account my conversion factor. I am just going to be looking at the original number in the problem itself. That's what's going to determine the amount of sig figs in my answer. So looking at this original number, this first 0 does not count because I can't start counting till I get to my first non-zero number. So I'm going to start counting at the 5 because that's my first non-zero. The 0 that comes after the 5, yes, it does count because there's a decimal and I already started counting. So that's going to give me 2 total significant figures, which means I'm going to want 2 total significant figures in my answer. So how many is 2? That 0 doesn't count, that 0 doesn't count, because I can't start counting till I get to the 1. So here's 1 sig fig, and then the 2 is going to be my second sig fig. So I'm going to stop there. But when I stop there, I want to make sure to look to the number next to it. So is that 2 going to stay a 2, or is it going to round up? In this case, it's going to round up to a 3. So let me go ahead and erase this. And my answer to the correct number of sig figs should be 0.013 meters. So half an inch is equal to 0.013 meters. Let's look at the next one. So the next one, we're looking at mass, right? Grams, ounces, those are mass amounts. Grams is metric, ounces is English. So we are once again using the English to metric conversion factors. We're going to look in the mass section. So let's see, I'm looking for grams and ounces. Do I have a conversion factor going directly between grams and ounces? Yes, I do. So the conversion factor that I'm seeing, and yours might be different, and if it is, go ahead and use it and see if you get the same answer, because you should. It shouldn't matter what conversion factor you use as long as you are canceling out the units you don't want and keeping the units you do. So here's the one I found, going between grams and ounces. So one-step problem. Once I have the conversion factor I need, start my railroad tracks. I'm going to start with what was given in the question itself. So I'm starting with the 56.8 grams. Now I take this conversion factor and I figure out, okay, do I want the ounces on top or the ounces on the bottom? Well, in this case, I'm going to want my ounces on the top because ounces is what I want my answer in. And grams I want to get rid of. So if I want to get rid of grams, I need it to be on the bottom so that grams, grams, opposite side of the horizontal line, meaning they cancel, and ounces are the units I'm left with. So once again, notice I'm dividing because that horizontal line is a division line. So I'm taking 56.8, dividing by 28.35, and I get 2.003527337. Okay, lots of numbers, right? So I'm going to go ahead and look at how many sig figs I actually need. So going back to my original starting number, remember we're not taking into account the sig figs and the conversion factor because that's an exact number. So we have 1, 2, 3. All 3 count because they're all not 0. So that means in my answer, I'm going to want 3 sig figs. So when I look, I have 2.0035. I'm just going to write a few of the digits. We just said we wanted 3. We start at the 2, so 1, 2, 3. So that means I'm stopping at that 0. Now I want to look to the number next to it. Does that stay a 0 or do I round it up? It's a 3. So that's going to stay a 0, right? 4 or below, it stays the same. 5 or higher, we round up. So 2.00 ounces is the correct answer with the correct amount of sig figs. These zeros count because there's a decimal and we started counting at the 2. All right, let's look at the next one. We have 0.75 quarts going to milliliters. So quarts, milliliters, that's volume. So we're looking at the volume section. Now in the volume section, let's see, I only have one conversion factor that has quarts in it, and it goes from quarts to liters. So let me go ahead and use that one. So I have 1.0, oh, let me write it in blue to keep it consistent, sorry. So 1.057, and that's equal to 1 liter. Why did I pick that one? It doesn't go to milliliters, it goes to liters. Well, if you can't find a conversion factor, a one-step conversion factor like in these two that goes directly between the two units that you have in the problem, then what you want to do is get somewhere in the realm. So what I did here is, if I use this conversion factor, I'm going to go from quarts to liters. So I went from quarts to a metric unit, and that's what I'm trying to get into, is a metric unit. So if I can go to liters, my next step will be to go from liters to milliliters. Okay, so let me show you my plan here. So I'm going to start at quarts using this conversion factor. Let's call it conversion factor number 1. Will get me from quarts to liters. Okay, but I don't want to stop at liters. I want to get to milliliters. So that means I'm going to need a second conversion factor to go between liters and milliliters. So what would my second conversion factor be? Well, I need to look up a conversion factor that goes between liters and milliliters. And notice, letter in common. So if there's a letter in common, that tells me this is metric to metric. So I'm not going to look here. That's not going to help me. Okay? What I need to look at is, I can either use this table 1.5 or the cheat sheet that I made deciphering table 1.5. Okay, so this cheat sheet gives you conversion factors similar to what you see in the English to metric conversion factors. So if I'm going between liters and milliliters, what I want to do is I want to go to the prefix and I want to go down to milli. That's the area I want to look in. And since we're talking about volume, I'm going to go all the way to the end, the column that says liters. So what I see here, let me just outline it. Might be kind of hard to see because it's far away from the camera. But this is the conversion factor I'm going to use. It says 1 milliliter is equal to 10 to the negative third liters. So that brings me to my second conversion factor. Going to be 1 milliliter is equal to 10 to the negative third liter. So now I have two conversion factors, going from quarts to liters and then going from liters to milliliters. So now that I have the two that I need, I can start my railroad tracks. I'm going to want more room, so I'm going to erase this to give myself some more room here. Bring it up top. Remember, what always goes in this upper left-hand corner? The number that the problem started with. Okay, now we're going to use conversion factor number 1 to go between quarts and liters. So I'm going to want the quarts on the bottom so that it cancels. That'll put my 1 liter on the top. This is going to have quarts and quarts canceling. So if I stopped right here, I would be in liters. Okay, I'm right here. But I don't want to stop there. I want to keep going to get to milliliters. So that's where this second conversion factor is going to come into play. And for this second conversion factor, now I'm going to want the liter portion on the bottom so that liters and liters are on opposite sides of the horizontal line, and they will cancel. That'll put my 1 milliliter on the top. So liters cancel. Now I can solve. Now remember, horizontal lines are multiplication, and that one's the division. Sorry, vertical lines are multiplication, horizontal is division. I said that wrong. So what are we essentially doing? We're doing 0.75 times 1 times 1. So that's all on the top. We're going to divide that by what's on the bottom, and that's 1.057 times 10 to the negative third. So entering that into the calculator, we get 0.75 divided by 1.057 7. And I get 709.555, lots of digits. But how many digits do I actually want? Look back to the original number. 1, 2, so that's 2 sig figs. That means I want just 2 sig figs in my answer. This is a hard one to round, actually. Glad we did this one. So 7, that's going to be the first significant figure, and then this 0 is going to be the second. So that's where I stop. Okay, remember, you always want to look at the number next to it. So is that going to stay a 0, or are we going to round up? Well, there's a 9 next to it, so we're going to round up. So 7, 1. Is that correct? It's the correct number of sig figs, but it's not the correct answer because I just went from 700 down to 70. Okay, so what I need to do is I need a placeholder in place of this 9 so that I can stay in the 100 range. But the number that I need to put here cannot be a significant figure. So what's the only number that is sometimes not significant? A 0. A 0 is the only one that sometimes doesn't count. So as long as I don't put a decimal there, that 0 does not count. I still only have 2 sig figs. I'm in the 700 range, so I'm good there. And then I just need to make sure I'm including my units. So 0.75 quarts is equal to 710 milliliters. We're going to do a metric to metric one, going from kilometers to micrometers. All right, so conversion, what type? Let's see, we got meters, meters. Letter in common, it's metric to metric. So if it's metric to metric, we're going to be looking at this guy here. So what conversion factors are we using? Well, we're going to be looking in this meter range here, right? Which 2 spots specifically? Well, the kilo, so the K, and the micro, that little mu symbol. So those are the 2 conversion factors I'm going to use. So for the kilo, we have 1 kilometer is equal to 10 to the 3rd meters. So that's going to get me from kilo to meter. But then I also need to go to micro. So I'm going down to micro, and that conversion factor is 1 micrometer is equal to 10 to the negative 6th meter. So let me show you my plan. I'm starting at kilometer. That's what the original number was given to me as. I'm going to go to meters using this conversion factor, kilometer to meter. Then I'm going to go from meter to micrometer using the second conversion factor. Start my railroad tracks with my original number given to me. Got 4 zeros there. Ah, it's a big number there, isn't it? Starting with conversion factor number 1, putting the kilometer portion on the bottom, the 10 to the 3rd meters on the top. Canceling out my kilometers, opposite sides of the horizontal line. Next, my second conversion factor, putting the 10 to the negative 6th meters on the bottom so that meters are on opposite sides of the horizontal line. Multiply across, divide what's on the bottom. So what that's going to get me is 0.0000120 times 10 to the 3rd divided by 1 times 10 to the negative 6. And I get 12,000. But I need to take into account significant figures. So let's look. Going up here, can't start counting till I get to my first non-zero, so that at the 1 is where I start counting. So that's 1 significant figure, 2 significant figures, and then this last 0 does count because of the decimal and we started counting. So 3 sig figs. So I need 3 sig figs in my answer. There is no way to have 3 sig figs when it's in normal notation. So when this happens, you need to represent your answer in scientific to get the correct number of sig figs. So put this number in scientific notation. So to do that, you want one non-zero number to the left of the decimal. So it's going to go between the 1 and the 2. So I get 1.2 times 10 to the, so what's my exponent? Well, it's how many times I have to move the decimal point to get it here. Now, there was no decimal point originally, so I start at the end of the number. I have to move it 1, 2, 3, 4 times to get it between the 1 and the 2. It's going to be a positive 4 because I moved to the left and because my original number was large. It was greater than 1. So this is scientific notation representation of that number. But remember, the reason I did this was so that I could have 3 significant figures. And how many do I have? I just have 2. So to get 3, I need to add a 0. And this 0 counts now because in scientific notation I have a decimal. So by having that decimal, anything after the 1 and the 2 counts. So this would be the correct answer for that conversion. So I want to show this one because we have 2 different units. So we have a lot of different things going on here. So when you're doing this, it's good to approach it. It's the same as writing 1.29 grams over 1 liter. That's what that means. And this means how many kilograms over 1 milliliter. So we're doing 2 different things here. So along the top, we're going from grams to kilograms, so we need a conversion factor for that. Along the bottom, we're going from liters to milliliters, so we need a conversion factor for that as well. So we're looking at 2 different conversion factors. So my first conversion factor that I want to find, it is metric to metric, gram, is going between kilograms and grams. So I'm going to go to the grams section, find where my kilo prefix is, and the conversion factor I have for that is 1 kilogram is equal to 10 to the 3rd grams. The bottom conversion, liters to milliliters. So I go to the liter section, more specifically the milli prefix, so down here to milli. The conversion factor that applies there is 1 milliliter is equal to 10 to the negative 3rd liters. So I have the conversion factors to get me from grams to kilograms and then from liters to milliliters. So let's see how this looks on the railroad tracks. Remember, we still start with this number. The difference though is the gram portion's on top, but now we're also going to have something down here because we haven't had anything down there yet. What goes down there? The 1 liter. Okay. We're still approaching it the same, canceling out what we don't want, keeping what we do. It does not matter what conversion factor you use first. You could use either one. I'm just going to use the top one because it's labeled number 1. So if I use this conversion factor, I want to place it here so that the grams is on the bottom so that it cancels out. I'm going to put the 10 to the 3rd grams on the bottom, and then that means the other side of the equal sign, the 1 kilogram, goes on top. So now I have kilograms. So my second conversion factor, I want to cancel out liters. And remember, we just need them on opposite sides of the horizontal line. So that means this liter portion, the 10 to the negative 3rd, needs to go on the top so that these liters are on opposite sides of the horizontal line and they cancel. That's going to put the other portion of the conversion factor, the 1 milliliter, on the bottom. And that's good. That's what I want because the units are kilogram per milliliter. No, kilogram per milliliter. So we're good there. So now multiply across and then divide those two lines. 1.29 times 10 to the negative third divided by 1 times 10 to the third. I have a feeling those are going to cancel. There we go. So my calculator spits out this guy here. Yours might give it to you in scientific notation depending upon how you have your settings set up. So both of these are the correct answer. Just depends if you want it in normal or in scientific. And notice I also kept my sig figs. We had 3 sig figs there, and we have 3 sig figs in both of these answers.